let us discuss about the equation of a straight line in a symmetrical form. The symmetrical form of equation of straight line. Right. What the statement says, the equation of straight line passing through the point A of x1, y1, z1 and having the DCS L, M, N is x minus x1 by L, y minus y1 by M is equal to z minus z1 by n. Okay. Now I take, this is a y-axis, this is x-axis, z-axis. This is a straight line passing through the point A of x1, y1, z1 and P of x, y, z be the point on the line. This is a line. So now if I draw like this, draw a perpendicular, you call it as L, you call it as M. LM is nothing but projection of AP on y-axis. If I take this as projection of P on y-axis 0, y, 0, the projection of A on y-axis what? M, that is 0, y1, x1, y1, z1. You take this 0. Right. Now you draw a line parallel to y-axis. Let this line makes an angle theta. You take it as Q, right? This PQ is nothing but LM. So therefore, now I can write this one as LMS. So this LM is taken, has to be what? Common. Now before that, the distance between them is what? R. AP is equal to R. Now I can write the proof of this one is very simple. Let P of x, y, z be a point on the line which is passing through A of x1, y1, z1. Let AP is equal to R and AP makes an angle theta with the PQ. PQ is same as y-axis. Now from figure L, M be the feet of perpendiculars from P and A on y-axis respectively, and L, M is equal to PQ. From triangle from triangle APQ, cos theta is equal to PQ by AP is same as PQ by R. Now I can write PQ is equal to R into, you take this, look here, this point, if you want you can put theta is equal to beta. Why? The angle made by the line with y-axis what? Let it be beta. With x-axis alpha. With what? Z-axis what? Beta. So therefore, now I can write cos theta where theta is equal to beta. So therefore, PQ is nothing but what? LM. LM is nothing but R into cos beta. Why? Theta is nothing but a beta. Angle made by the line with y-axis beta, with x-axis alpha, with z-axis what? Gamma. So therefore, but here I can go for LM is nothing but distance between these two lines. I can write that is y minus y1 is equal to R into cos beta is same as R into M. M means what? L is equal to cos alpha, M is equal to cos beta, N is equal to cos gamma. So therefore, now I can write that is y minus y1 by M is equal to R. Similarly, with x-axis, x minus x1 by L is equal to R. Similarly, with z-axis, z minus z1 by N is equal to what? R. On the whole, x minus x1 by L, y minus y1 by M, z minus z1 by N. All are equal to what? R. So therefore, hereafter, the symmetrical form of the equation of the straight line passing through the point A of x1, y1, z1 and having the DCS L, M, N is given by x minus x1 by L, y minus y1 by M, z minus z1 by N is equal to R. Look, instead of direction cosines, he may give direction ratios. What they are? A, B, C. In that case, you can write the equation of straight line passing through the point x1, y1, z1 having the DCS is x minus x1 by A, y minus y1 by B, z minus z1 by C, right? Is equal to what? R. Is equal to R. Let us see. Right. Let us see the example. Equation of the straight line. Now, let us see the example for this. Equation of the straight line passing through the point A of 3, 4, 5 and having the DCS 2, 3, 4 is dash. Now I can write the solution of this one is the equation of straight line passing through the point A of x1, y1, z1 is equal to A of 3, 4, 5 and having DCS L, M, N is equal to 2, 3, 4 is x minus x1 by L, y minus y1 by M is equal to z minus z1 by N. Come on, substitute the corresponding values. This becomes x minus 3 by what? 2, y minus 4 by 3, z minus 5 by 4, This is nothing but the equation of straight line passing through the point A of 3, 4, 5 and having the DCS 2, 3, 4. Let us see what's the equation of a straight line having a DRS. Note, equation of straight line passing through the point A of x1, y1, z1 and having DRS A comma B comma C is x minus x1 by A, y minus y1 by B, z minus z1 by C. Earlier we had a direction cosines. The direction cosines are nothing but the direction ratios. So therefore, x minus x1 by A is equal to y minus y1 by B is equal to z minus z1 by C. So earlier we have taken is equal to R. You can also take T, say, where T is any scalar. Scalar is always denoted by real numbers in vectors. So therefore, now I want to find out x comma y comma z. This is a straight line passing through the point x1, y1, z1 and meanwhile we have taken P of x comma y comma z is a point on it. I want to find out the coordinates of the point P. The coordinates of the note is, next note is the coordinates of any point on the line x minus x1 by A, y minus y1 by B, z minus z1 by C is equal to T, which implies x minus x1 by A is equal to T, y minus y1 by B is equal to T, z minus z1 by C is equal to T, right? Now which implies x minus x1 is equal to AT, y minus y1 is equal to BT, z minus z1 is equal to CT, which implies x1 is equal to x1 plus AT, y is equal to y1 plus BT and z is equal to z1 plus CT. So therefore, now P of x, y, z can be written as x1 plus AT, next y1 plus BT, z1 plus CT, where T belongs to R. Where T belongs to R. This is how you can find out the coordinates of any point on the line passing through the point x1, y1, z1 and having the DRS A comma B comma C, right? Similarly, you can also find out on what? A line having a DCS L comma M comma N. So therefore, for different values of T, different points you get where T belongs to R, right? In the same way, equation of straight line passing through 2 points A of x1, y1, z1, B of x2, y2, z2 is given by x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus z1. This is nothing but the denominator represents the DRS of the line joining of the 2 points AP. Earlier we have taken x minus x1 by what? A. A is nothing but x2 minus x1. Y minus y1 by what? B. B is nothing but y2 minus y1. C. Z minus z1 by C. C is nothing but z2 minus z1. So therefore, let us take example on this. What's an example? The equation of a straight line passing through the points A of 1, 2, 3, B of 3, 4, 5 is dash. Let us take this point as x1, y1, z1. You take this point as x2, y2, z2. So therefore, now I can write equation of line is x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus, just you substitute x minus 1 by 3 minus 1, y minus 2 by 4 minus 2, z minus 3 by 5 minus 3. So therefore I can write x minus 1 by 2, y minus 2 by 2. Therefore z minus 3 by 3 is the equation of a straight line passing through how many points? 2 points. That is x1, y1, z1, b of x2, y2, z2.